Today we're moving on to 1.4-Solving equations for specific variables. So we're moving on to the next section. We're no longer just simplifying expressions. We're going to work with equations again. So there's going to be some different scenarios that we're going to talk about today. So this next slide of material you're definitely going to want to write down. So if I underline it, then it's important enough that you need to write down when you're doing your notes. Okay, so there's going to be three types of solutions that we're going to be talking about. We're going to be talking about always true solutions, and this happens when the variables eliminate and the two sides of the equal sign are the exact same. So go ahead and write this down. If you need to pause the video to have time to write, go ahead and do that. And the examples here, if 4 equals 4 or 0 equals 0, that's always going to be true. 4 is always going to equal 4, and 0 is always going to equal 0. So when we're solving these equations and we're getting them in lowest form, if we're left with a statement that's true, like 4 equals 4, 0 equals 0, then we're going to say that the solution is always. The next type of solution we're going to deal with is sometimes. So sometimes true, and this happens when the variable stays and you get one value for the variable you're solving for. So for example, we might get x equals 3 or y equals -5. So this is your typical solving of equation. Those are usually sometimes true. Why is it just sometimes true? Well, x in every equation that you ever solve, is x always 3? No, but it sometimes is if you're solving that specific equation. Same with y equals -5. Y isn't always going to equal -5. It depends on the equation that you're solving. But sometimes it might. So far we've talked about always and sometimes. And then the last one we need to talk about is never. So sometimes when you're solving these equations, you're going to come across an equation that's never going to be true. And this happens when the variables eliminate, so there's no longer a letter involved. And then the two sides of the equal sign are different. So for example, 0 will never equal 3. Those are not the same number. Or another example, -5 will never equal 7. So you can't have two different values on both sides of the equal sign because that statement is false. So we're going to solve some examples, and we're going to eliminate some variables, or we might be left with a variable, and then we have to decide if it's always, sometimes, or never true. So go ahead and write down this first example, and the directions say, is the equation always, sometimes, or never true? So you've got 11 plus 3x minus 7 equals 6x plus 5 minus 3x. So the first thing we always do when we're solving equations is we combine like terms and try to get the two sides of the equal sign in their lowest terms possible. So on the left hand side we've got 11 and a minus 7. We can put those together and get 4. Just bring down the plus 3x. And then on the right hand side we've got 6x and minus 3x, so we can put those together and that's going to give us 3x. Okay, and just like always when we're solving equations, we want to move the variables and combine those together first. So I'm going to subtract 3x from both sides. And notice that both sets of variables are going to eliminate because we've got 3x and -3x. So all I'm left with is 4 equals 5. Okay, now we need to state, is that always true, sometimes true, or never true? Well, 4 doesn't equal 5, so it's a never. So both the 4 equals 5 and the word never are my two solutions for this. You have to make both. Okay, the next one, we've got 6x plus 5 minus 2x equals 4 plus 4x plus 1. All right, starting the same way we did the last time, we need to combine like terms on the left-hand side. 6x minus 2x would be 4x. Bring down my plus 5. And then on the right-hand side, I can combine the 4 and the positive 1 to get 5. And then bring down plus 4x. Just like we did last time, we need to move my variables and get them together. So I'm going to subtract 4x from both sides. And it just so happens that they both cross out. And I'm left with 5 equals 5. So is that statement always true, sometimes true, or never true? Well, 5 is always going to equal 5, so that would be an example of always. Remember, you have to have the solution and the word in order for your homework to be marked correct. Okay, last one. Last example. We've got negative 27 plus 6y equals 3 times y minus 3. So again, first step, we're going to look on the left-hand side, see if there's anything I can put together to make it in smaller terms. I can't combine negative 27 and 6y. They are not the same. On the right-hand side, I don't have anything I can put together yet, but I do have a number outside of parentheses, which means I need to distribute. So I'm just going to rewrite the left-hand side first. And on the right, I'm going to distribute 3 times y is 3y. 3 times negative 3 is negative 9. Again, no like terms, so I need to move from side to side of the equal sign. So I'm going to put my variables together first. Subtract 3y from both sides. 6y minus 3y is 3y. And then I'm just left with negative 9 on the right. Okay, now I'm going to add 27 to both sides because I'm trying to get the y by itself. So 3y equals 18. You can do that in the calculator. And then my last step would be to divide by 3. And 18 divided by 3 is 6. Okay, so there's my solution. Now I need to say, is y equal to 6 always true, sometimes true, or never true? Well, the hint here is that there's the variable left, so that automatically means it's sometimes. Sometimes y is going to equal 6, but not always. All right, and you can find your homework on Google Classroom.